Well, hello. Welcome to Math Blossoms, where growing in mathematics is natural. I'm the teacher, Miss G, and for today's math topic, we're going to learn a little bit about inequalities, how they're very different from equations, but also the way you solve them is kind of similar. So we're going to look at that very closely today. We're going to learn not just how to solve them and what they are, but also how to graph them. So stick around and let's get started with this. Okay, our first question is, what are inequalities? Inequalities are the relation between two expressions that are not equal, employing a sign such as the not equal to symbol, which is this one right here, greater than, which is this symbol, and then the less than symbol. Also, we have less than or greater to, which is this symbol here, and the greater than or equal to symbol, which is at the bottom there. Okay, so let's do just a couple of them so you can understand a little bit about what we're talking about here. Let's pull our pen out here, and we're going to do some of these here. Actually, let me use green so it'll stick out a little bit. There we go. Okay, so 8 is clearly bigger or greater than 4. So we need to use the greater than symbol right here. And if you notice, the big opened end, we call that like the opening of Pac-Man's mouth or the opening of a big crocodile. It's like it's open towards the bigger number. And then the pointy bit of the greater than symbol is pointing towards the smaller number. If you look at the next one, -8, -4, -8 is actually less than -4. Negative a number is, the smaller it is. So -8 is definitely less than -4. So when we do that symbol, the pointy end is pointing towards the 8. This is the less than symbol. Okay. And I always also kind of, another way you can remember how they're pointed is the less than symbol kind of looks like a sideways L. So you could like write the word less. It kind of looks like a sideways L to me when you're reading it from left to right. So that's another way to kind of think about that. Let's see here. I'll erase that so you know. Okay. And then 3x, of course, is less than the 5x here. So we're going to also use the less than symbol. And then over here, 4.7 is actually less than 4.72 because 4.7 is actually 4.70. But we just don't write the zeros because it does not change the value of the number when we write the zero there. And definitely 70 is less than 72. So this is kind of an idea of what we're talking about here when we're dealing with negative and positive numbers and which ones are greater and which ones are less than. Now, when we're solving two-step inequalities or any inequalities, we're going to be using the same steps that we use to solve regular equations. So if you have not watched any of the equation videos, I recommend you watch, the one-step, the two-step, the distributed property, all of those videos, and learn about the don't call me after midnight or the DCMAM method of solving multi-step equations. Because when you're given an inequality, you're going to have to be using those same steps to solve it. And so here's some examples about that. The solution in an inequality, though, is not just one number. When we're solving an equation, generally, there's just one solution, or in special cases, we have infinite solutions, right? Well, in an inequality, there's always multiple solutions. And so when you're looking at a solution to an inequality, we have what we call a solution set, which is okay. I thought I had, there we go. Solution set. I don't know why this thing doesn't work well for me. Solution set. So we're talking about like more than one solution. So for instance, in this here, let me get my green pen again. Here we go. In this solution here, we have x is greater than 4. So that means the value of x is every number greater than 4. Not just 5, but like 5, 6, 7, 8, 9, 10, and so forth, all the way through to infinity. Okay. With this one here, we have x is greater than or equal to 8, which means that the solution set for x is greater than or equal to 8 means that it's not just 8, but every number after 8, like 9, 10, 11, 12, and so forth. And then this one here, x is less than 3. That means x can be any number less than 3. So it could be 2, it could be 1, it could be 0, it could be -5. As long as it's less than 3, it's fine. And it does not include 3. When it's just less than 3, that means it doesn't include 3. Just like on this one, when it's greater than 4, that means it doesn't include 4. It's every number greater than 4. And if it helps you to replace the inequality symbol with equal symbols until you understand how to solve them better, you can do that. So like on this one here, I just moved up some equal symbols. And as you can see, we're still using the add subtract step from the DCMAM steps to solving equations. We're still using those. Like I had to cancel the 5 out, so I subtracted 5 from both sides. And then we had to cancel 3 out, so we divided by 3 on both sides. It's the same kind of steps, right? Okay, so that being said, I put up the DCMAM on the screen, and we're going to try solving some of these, but you need to be aware of one big difference, and that is the very last step. Oops, let me go back. This last step here, this multiply and divide step, okay? If the number you are multiplying and dividing by is a negative, then you must reverse the inequality symbol. So as you can see on this one here, the number that they are dividing by is -3. And this is always on that final step when you're solving equations and inequalities, the multiply divide step. So if you're multiplying or dividing by a negative number, then you have to reverse the symbol. So see how they had greater than first and they reversed it to less than? That's why they did that. Because that's the only big difference. That's the only big difference between solving an inequality and solving an equation. There are differences to the graphs as well, but we'll talk about that in a little bit. And that's basically the only big thing you have to remember. And that doesn't mean just dividing by a negative. That means if I had to multiply times the negative number, then I would have to flip the symbol. Now that doesn't mean your answer has to be negative. The answer can be a positive number and still have to flip the symbol, okay? It really is focused on what number you are dividing or multiplying by. If it's negative, flip that symbol, even if your answer is positive, okay? So let's try some two-step inequalities. We're going to primarily be using the last 2 steps, add, subtract, multiply, and divide. I didn't put any on here with distributive property, combine like terms, and moving the variable, because that's that you can find in the equation videos. So we're more focused on the difference between solving these inequalities and solving the equations. So here we have a 2-step equation. We're going to start with the add subtract step. What is being added to our variable is the 4. So we're going to subtract 4 on both sides first. And when I say both sides, I mean both sides of the inequality. We're going to rewrite our equation, -2x, and then this canceled out because it's 0. And now we have 12. And then so we did this step. And then the multiply divide step, we're dividing by a -2. We're dividing by a -2, which means I'm going to have to use that reversing the symbol thing. So x is not less than -6. It's going to be greater than -6 because we have to flip that symbol, because 12 divided by -2 is -6. So there's one for you. And I'm just going to put this up here just in case you guys forget about this. This is the big difference between solving an inequality and solving an equation. So here's another one. Let me change colors real quick. We'll make it purple this time. Okay, so the number being added or subtracted with our variable is the -2. The 3 is being multiplied times the variable. So we need to cancel out the -2 first. And to do that, I'm going to add a 2 because I know that a negative plus a positive will zero out. Okay, so I know that's an add there. But if basically what I'm doing is I'm subtracting a negative. And we know that subtracting a negative is the same as a positive. So if you see a negative, just put a positive down there if you're trying to add and subtract to cancel something out. We are going to add 2 to this side of the equation also, and this is going to end up being a negative 21. When I rewrite my equation, leaving out the stuff that I canceled out, I end up with, because I'm leaving all of that out, 3x, oh, not equals. See, I already messed up. It's so easy to do that when you're so used to doing equations over and over again. Okay, so this is greater than. I bet some of you will make that mistake as well, and it's okay. Just fix it if you find it. 3 divided by 3, we're on that last step, multiply, divide, because we finished this one. Now we're on this one. And when I divide negative 21 by 3 over here, I'm going to end up with 1x greater than a negative divided by an, it's not a negative, it's a positive. Negative divided by a positive 3 is negative 7. And since the number that I'm dividing by is not a negative number, I do not have to flip that symbol. So this is the final answer. X is greater than negative 7. And so let's try and know it. All right, so the next one, what's going on? There we go. This one is 5 is greater than 2 plus x divided by negative 3. Again, let me change colors again. We'll change it to red this time. Okay, so we're going to first cancel out the 2 because 2 is what's being added or subtracted with my variable. And since it's a positive 2, I'm going to subtract 2 to zero that out, to cancel it out. I'm going to subtract 2 on this side and get a 3. So when I rewrite my equation, I have 3 is greater than, I don't have to write this because it's canceled out now, x divided by negative 3. Now, since x is being divided by negative 3, when I get to my final step here, the multiply divide, I have to do the inverse of division, which is multiplication. So to get this negative 3 to be canceled out of my denominator, just as I did in the one-step equation video, I'm going to multiply. And that will cancel my denominator out, and we will just be left with an x. Oops. An x. And then when I divide this, not divide. When I multiply this side by negative 3, I should get a negative 9. Put a little dot there. Negative 3. And negative 3 times positive 3 is negative 9. And because the number that I multiplied times is a negative number, this number here, I am flipping my symbol. So I need to have, instead of greater than, I need to have less than. Did not mean to make that little mark there. So we'll erase that little mark there. Okay, so our final solution is negative 9 is less than x. Do I have any more? I think they might have one more. Let's see. Oops. Nope, that was it. Okay, so again, you're just using the same DCMAM steps when you solve these. For these 3, we just had 2-step equations, so we just use the 2 steps. But just don't forget about this big thing here, okay? If you multiply or divide on this final step by a negative number, that's when you flip that symbol around to make that inequality correct, okay? And again, this is a set of numbers that are the answer, not just one number. This means x is greater than all numbers greater than negative 6. This means x is greater than all numbers negative 7. And this means x or negative 9 is less than x. But x means that it's all numbers greater than negative 9, basically. Okay, so this is inequality word problem vocabulary. This is probably the most challenging part of inequalities because when you are given a word problem, you have to determine whether they're talking about an equation or an inequality. So here are some words to look out for, and we're going to practice some of these, okay? And if you think about it, a lot of these you use in your everyday language. You just don't realize it. So we'll give some examples. All right, so the first one is Mary's apples are fewer than size apples. So when you see that word fewer, think less than, because what they're saying is Mary's apples are less than size apples. If they're fewer than size apples, then they have to be less than size apples, right? Let's do another one. Patricia's test grade exceeds Ned's grade. Exceeds. Okay, so if you look down here, exceeds is on the greater than symbol category. So that means Patricia's grade is greater than Ned's grade. If it exceeds Ned's grade, then that means it's bigger, or exceeding it means it's, more than Ned's grade. April's absences from school are at least 7. So we're talking about at least here. Okay. Here was exceeds, here was fewer than, and this one is at least. So if it's at least 7, then that means it's 7 or more, right? So that would be greater than or equal to, let me find it. Yep, there it is. At least greater than or equal to 7. That means it includes 7 in that sentence, right? Or expression. Okay, and the last one here, Cynthia has up to 4 meetings to attend this week. Up to. That would be less than or equal to. That means she's not going over the 4 meetings, but she has meetings up to at least 4, right? Or up to 4. So that would be less than or equal to. So again, this takes practice, just, being able to think about it and think, do they mean more than that, or do they mean less than that? Do they include the number? Do they not include the number? And these are words that can kind of help you determine that. So it's good to study these just in case you see them in a word problem. How do we graph inequalities? This is actually not too challenging if you know what to do. First of all, graphing a point is just labeling a dot on the coordinate plane or on a number line. Okay, so if I was trying to plot x equals 3, I would just put a little dot right there. In between the 2 and 4 would be the 3, and that's where my point would go. Okay, but if I'm graphing an inequality, I have some of these with closed circles and some of these with open circles, and they actually mean something. Okay, when I say x here is greater than or equal to 3, I'm closing that circle because that means it's including the 3. Okay, it's all numbers 3 and above. So whenever I graph that, I'm putting a closed circle and then an arrow pointing to the right of the 3 because it includes all numbers for infinity above 3 and above, right? Now this one is x less than or equal to 3. So I'm including the 3 again because it's less than or equal to 3. So I'm closing that circle in, but this time my arrow is pointing the opposite direction because it includes the numbers that are less than 3, including 3. Now, when it's just x is greater than 3, like down here, we use an open circle, and that indicates on our graph that we don't include 3, but it does include every number greater than 3. Okay, and the same for this one here, x is less than 3. That means we are not including 3, but we are including every number in our solution set that is less than 3. Here is a couple of more examples of what this means. Here's x is greater than 2, so we did not include 2, but we are including all numbers greater than 2. X is less than 5, so again, open circle, we're not including 5, but we are including every number less than 5. And then over here, the filled in circle means that the value is included. So if x is greater than or equal to 3, then we're going to color that circle in and then point our arrow towards all the numbers greater than 3. And then this one's x is less than or equal to 6. So we're coloring that circle in because it includes 6, and then all of the numbers less than 6 as well. All right, so great job, y'all. So remember that we solve inequalities the same way we do equations using the DCMAM steps, except for one big difference. Remember that on the last step of DCMAM, the multiply and divide step, we flip the inequality symbol around if we multiply or divide by a negative number. So we have to reverse that symbol if we're multiplying or dividing by a negative. The inequality does not have to have a negative answer. It's what you're dividing by or multiplying multiplying by that counts, right? Remember to pay attention to clue words that may be in real world word problems to determine which inequality symbol to use. And remember that when graphing inequalities, an open circle is used for less than or greater than symbols because the solution set does not include the number on the graph. Remember that when graphing inequalities, a closed circle is used for less than or equal to and greater than or equal to inequalities because the solution set does include the number on the graph. So hopefully today's lesson allowed you to learn a little bit about inequalities and how they're kind of similar to equations, but also very different than equations. And now it's time for me to say, it was lovely teaching you math today. See you later.